Learned a lot. I'm no longer a fool now. This is best time to buy and sell stock with Cooldown. Okay, so if you're familiar with this class of problems, there's several lead code problems that deal with timing the market, right? Trying to determine what is the best time to buy and the best time to sell. Maybe you can sell and buy multiple times. Maybe you can only buy and sell once, whatever. But the idea is about optimizing the total amount of money that you can make, right? And intuitively, what does that mean? That means you try to buy low and you try to sell high. Or if you're like me, you buy high and you sell low. But now, intuitively, it just means that you're trying to maximize, that delta between the price you buy and the price you sell. Now, each of these problems usually have a unique constraint that makes the problem itself unique from the other buy and sell stock problems. But usually it's either going to be dynamic programming or a greedy approach, right? And that makes sense, right? Greedy makes sense because you're greedily just trying to decide, like, if I can only buy and sell high, buy low and sell high, then greedily I should try to buy as low as possible and then sell as high as possible, right? And then dynamic programming makes sense because there's this idea of like, well, the best thing to do here, if I sell here, well, then what's the best time that I could buy before this, right? Based on a system of transactions. So these both seem like very, I guess, obvious approaches. But let's determine, which one of these, or maybe there's something else that we're going to use to solve this problem. So let's go ahead and get right into it. So you're given an array of prices where price is I is the price of the given stock on the I day. If you've done other stock trading problems, this is very, very familiar. Find the maximum profit you can achieve. You may complete as many transactions as you like. Buy one and sell one share of the stock multiple times. Okay, so the constraint here is you can't like buy a million shares, right? You can't trade on a margin. You can buy a stock and then you can sell that stock. And then you can decide to buy again and then you can decide to sell again. But you can't sell if you haven't bought, and you can't buy something twice, right? So you either have a share or you don't have a share. And I think that's a good enough thing to state as an observation. We either are holding a stock or you're not holding a stock. Okay, so you're either holding or you're not holding, and that will become relevant in a moment. Okay, note you may not engage. Okay. There's one restriction. That restriction is after you sell your stock, you cannot buy a stock on the next day. So why would that be problematic within the context of trading? Well, maybe you buy and then you sell, and then the very next day after you sell, there's a cool down period where you can't buy again. But it just so happens on that cool down period day, the price plummets, right? So it plummets to zero, and you realize, oh wow, this is a way undervaluation of this stock intrinsically, so I should buy today. But you can't buy today because it's the cool down day, and then maybe the next day it goes back up to 100,000 billion quadrillion. So you missed out on your chance because you were stuck within that cool down period. So a cool down period is what? A cool down period, another way of stating what that is in terms of something that will make sense later, is a period. Cool down is a day you skip. We'll say that is a day you skip, okay? Because on a cool down period, it happens after you sell the stock, right? So you sell the stock, so you're not holding a stock currently, right? Because you sold it, you're no longer holding it, and you can't buy a stock, so you basically can't do anything, right? The only thing you can do after you sell a stock is buy a stock, right? So if you can't buy because it's a cool down, you basically skip that day. There's nothing you can do. The only operation you could do that day is buy, and you can't buy, so you're essentially skipping that day. So cool down is a day you skip, right? And I guess the third observation, which kind of corresponds to this first one, is if you're not holding, all you can do is buy. That's buy. If you're not holding the stock, you have two options. You can either buy or continue not holding. And all of this will make sense in a moment why I'm playing this weird game of trying to establish all these strange points, right? If you're not holding the stock, what can you do on that day? Well, you can either decide that you want to buy the stock that day, or you can decide that you're just going to continue to not hold, right? You'll say, okay, I don't like the price of the stock today. I'm just going to continue to the next day, and maybe tomorrow I'll consider buying, right? And if you are holding, what can you do? You can either sell or continue holding, right? So those are the only things that you can do within this state, right? So if you're not holding, you can buy or continue. If you aren't holding, you can sell or continue holding. Okay. These are kind of all the observations you need to solve this problem, and hopefully it's helpful in a moment. So when we look at this example, 1, 2, 3, 0, 2, so we have 1, 2, 3. Let's draw this a little bit better. So 1, 2, 3, 0, 2. And we'll model this system as a graph, right? So these are each of our days within this period, right? And, well, I guess, at any of these days, you can decide to do a few things, right? You can decide that you're going to buy the stock, and that's going to cost you money. So on the first day, you can decide that you're going to buy the stock, and that's going to cost you $1. So I'll correspond that to saying it's going to cost you -1. You gain -$1 by buying the stock. Or you can decide on the first day that you're going to do nothing, and that costs $0. Okay? You can decide to sell the stock on the second day, buy the stock on the second day, or do nothing. So again, you can buy the stock on this day, it would cost you $2. If you bought the stock on this day, it would cost you $3. If you bought the stock on this day, it would cost you $0. And if you bought the stock on this day, it would cost you $2. Okay. Similarly, you could decide that you don't want to buy the stock on this day. You don't want to buy the stock on this day. You don't want to buy the stock on this day. And you don't want to buy the stock on this day. So it's neutral, right? Basically, what this is saying is like, I look at this day and I say, you know what? I don't want to buy the stock this day, so it costs me nothing. I look at this day and I say, I don't want to buy the stock this day, so it costs me nothing. I look at this day and I say, oh, I do want to buy the stock this day, so now it's going to cost me -3. And then the final thing you can do is sell the stock. So if I sell it this day, I get $2. If I sell it this day, I get $3. I sell it this day, I get $0. And if I sell it this day, I get $2. So I guess the idea here is if you model the system as a graph, you'll notice that this is a dynamic programming problem, right? In a dynamic programming problem where the days are vertices and the edges and their corresponding weights are the what? They're the amount that you get or lose if you decide to sell or buy on that day. The problem is, though, with this graph as well, the system would say, oh, the optimal thing would be this path here. And why is that? Well, because we're not distinguishing between the idea of holding or not holding, correct? Because this will say, okay, I'll just do nothing. Oh, I'll sell. But you can't sell if you haven't bought, right? Because this first statement is saying you are either holding or you're not holding. So that information of holding or not holding is not captured within this graph, right? This is basically saying at any vertice I can sell, but I can only sell if what? I can only sell if I'm currently holding, right? I can only access this green node if I'm holding, right? I can only access this red edge, right? I can only access this green edge if I'm holding, and I can only access this red edge if I'm not holding, right? I can only buy if I'm not currently holding, and I can only sell if I am currently holding. So I need to somehow capture that fact within this graph so that that information is more clear. That way, I only can use this edge if I've spent money at some point buying the stock. So what we're going to do instead is slightly shift the way that we model this graph. And the way that we'll do that is by removing these links and thinking about, the states in terms of holding and not holding. So either you're holding or you're not holding. Seems simple enough. So we'll copy this graph, and then now we'll have states so that we know whether we're holding or not holding depending on the vertice that we're at. So if we're up here, that essentially means that we're holding the stock. And if we're down here, that means on that day, we're not holding the stock. So what can you do in the beginning? In the very beginning, you can decide that you don't want to buy a stock and that costs 0. Or you can decide that you do want to buy the stock, so now you're holding it and that'll cost you -1. If you're holding the stock on day 0 here, what are the things that you can do? Well, you can either decide, I'm just going to continue holding the stock to the next day, or I can sell the stock and gain $2 on a subsequent day. If I sell, and then if I decided to continue holding, I can walk through that, right? I can continue holding, I could continue holding, I could continue holding, I could continue holding through the whole system, right? To the very last day. Or I could decide to sell on every day, right? If I'm here, then I can sell and I'll get $3. If I sell here, I'll get $0. If I sell here, I'll get $2. And if I sell here, this will have to be determined in a moment, because there's a little bit, like most dynamic programming problems, right? On the edges, your recurrence relationship isn't as obvious, right? Versus when you're dealing with, you know, the central components, your recurrence relationship makes more sense, right? Like here, this isn't pointing, there's no node here, and then on this day, there's nothing that this points to, even though I could technically sell on this day. So we'll think about that in a moment, okay? Now let's think about in terms of not holding. What can I do if I'm not holding? Well, I can either decide to buy, right? I can either decide that I'm going to buy the stock for $2, -2, because I'm going to lose $2 from buying the stock at this day, or I can continue to not hold. So I can not hold through the whole system again. So it's the same rigmarole. Or on each of these days, I can decide to sell. I mean, I can decide to buy because I'm not holding. If I'm not holding, all I can do is buy or continue not holding. So if I buy here, it costs me -3. If I buy here, it costs 0. If I buy here, it costs -2. If I bought here, I guess it would cost, I'm not sure. We'll think about that again in a moment. So this is a classic form of another buy and sell problem, right? Because you're capturing the idea of holding and not holding. That way, these edges are only accessible if you're in the right state, right? The problem before was that I could continue to just sell. But now that we've, you know, kind of separated this graph based on holding and not holding, and this kind of idea of modeling your system as a graph and then thinking about states can be really useful and intuitive. So I definitely recommend that you approach the problem in this manner if you get stuck and you're confident that the problem is dynamic programming, right? So I'm breaking it up into states, and then the edges become clear, right? Because the problem before was that I could continue selling because I didn't make the distinction between holding and not holding, okay? So now that we're in this state, there's a small caveat, which is what? Well, you know, our second point was a cooldown is a day you skip, right? The cooldown is a day that you're skipping trading, right? Because a cooldown basically means that you just sold and you can't buy. So if you just sold, you're not holding. And if you can't buy, there's nothing you can do but continue to hold or not hold. So the problem here is this is basically saying, okay, I could buy here, sell here. I could buy again here. That's not right? Because if I sold here, I can't buy on this day, right? Because I buy here, this would become a cooldown day. If I sold here, this would become a cooldown day, so I'd have to skip this day, right? If I sold here, this would become a cooldown day, and I couldn't trade again to the subsequent day. So really what happens here is, well, these links are different, right? If I decide to sell, that's identical to skipping a day, right? If I decide to sell here, I don't get to I don't get to, what? I don't get to make a decision on the subsequent day because it's a cool down day. The cool down day is I'm taking a break, I'm cooling down, I'm taking a day off from trading, so I'm not going to get to buy, right? So since I sold this day, I'm actually going to have to skip a day, right? So now I have to skip a day. I still get $2, right? But I don't get to make a trade on that day since I've decided to sell on that day. So since I decided to sell on this day, I'm not going to get to trade on this day. So now I get the $2, but I have to skip that trading day. Hopefully that makes sense, right? Because the idea of a cool day is that you're skipping a day, right? So I took the cool day by selling, but now I can't buy for a subsequent day. Okay. And that means that all of these then, I get 3. The only weird thing is it's no longer the value of the edge I'm pointing at. It's the value of the edge that comes before it, right? I get 2, but I have to skip that day, and the next day I can start trading again is day 3. So for this solution, if we wanted to walk through the problem, you're going to, first day, I guess, you're going to buy. Okay. Then you're instantly going to sell. You have a cool day, so you have to skip this day. You're going to buy again. And then you're going to sell. So you get another cool day where you have to skip day 2. So what's the total of this? Where you get -1, plus 2 is 1, minus 0, plus 2 is 3. So now you see how the system works using this idea. So basically what we did is we just used this idea of holding and not holding to make a decision about what you can do. Since you're only either holding or not holding, each of the days, you're either holding or not holding. So if all the days are states, there's states where you're holding on that day, and there's states where you're not holding on that day. And then we thought about what you can do if you're holding or what you can do if you're not holding. So in those cases, if you're not holding, what can you do? You can either continue not holding or you can buy. If you are holding, you either continue to hold or you can sell. And then we just captured in the fact of a cool down. Since there's a cool down period, when you sell, you actually end up skipping a day because you rest, you cool down on that subsequent day. So this is then the system model in the graph. So if we think about this in terms of the edges and the recurrence relationship, right? Here, right, what is this in terms of what comes before it, right? The value you get from holding on a day, I'm going to call it H for holding, equals the maximum of either you decide to continue holding from the previous day, or the value you get from not holding on the previous day, plus the price, or you lose the price on the current day. So we'll make that red. So I'm going to try to make this clearer by using different colors. So basically what's happening here is I'll go through each of the terms individually. So the maximum value I can get holding on some certain day, this was the day, I can either continue holding from the previous day, so whatever this maximum value is from the previous day, or I can take this edge, which corresponds to not holding on the previous day, and then I have to spend the money to buy in order to buy on this day. Okay. Now, what is not holding for any value? Well, for this value, let's say the same day, right? So if you're not holding on a day, what does that mean in terms of your recurrence relationship? Well, it's just based on the nodes that you can access, right? So same deal here. I can either decide to continue not holding and get whatever value I get from that system there. So this is the max of not holding on the previous day. Or I can decide to sell 2 days before, all right? Because this is the day -1. This will be the day -2. So I can decide to get the value that I would get from holding from 2 previous days, right? So -1, -2, because I had to take that rest day. So that rest day is captured here. And then the value I would get is the price at the previous day, right? Here you get 2. 3, this is 2. Right here is, even though it's 0, the value you get would be 3 from this previous day. So I'd get plus price at the previous day. So that's your recurrence relationship in this problem. All right. So I guess the first thing is, right, the recurrence relationship kind of breaks down, right? So the first thing is we can just default here, right? We could say the holding at day 0 is the value of that day, the cost of the stock at that day, and not holding at 0 is 0, because the only way you could get here is by deciding not to buy, right? Versus in these other states, you have options. So that's something to think about. Okay. And with that, let's go ahead and try to start drawing out the solution. So we'll say holding and not holding, we'll just create them as default dicks. All right. And then we'll say holding at day 0, you would get the value. It would cost you negative the prices at 0. Right? Because if you're holding on day 0, you had to spend prices at $0 or units or whatever currency you use in order to get that. And if you're not holding at day 0, the best you could get is by not purchasing anything. You have no other option. If you're not holding on day 0, that means you didn't buy day 0. So that costs you 0. So we'll look at each day in range 1 to length of prices plus 2. So why did I put plus 2 here? Well, let's see if it's plus 2. The problem is well, I could decide to sell on this day, but I could also decide to sell on this day. So there's 2 additional states. I think. No, there's only one. Sorry, I'm trying to think about how this is supposed to work. There's only one additional state, right? Because this edge actually corresponds to selling on this day, but you have to skip it now since you decided to sell on that day. So there's one extra state here at the end. If that doesn't make sense, just look at this relationship and decide, well, the last day I could actually sell is this day. Because originally that would point here, right? If I decided to sell on this day. But now I have to skip it because, well, of course, because we have to skip a cooldown day. There's a cooldown day. Hopefully that makes a little bit of sense. Yeesh. All right, so now we just base it off our recurrence relationship here. So holding at the day equals holding at the previous day. So I'm just going to directly put in this information and the prices at the day. Okay. So holding at this day equals the maximum of deciding to hold on the previous day. Or we could decide to not hold on the previous day and buy at this day, which is going to cost us the price at the current day. Does that make sense? The problem is that this could end up being larger than length of prices, because at the end it will be. So maybe we'll just say times int day less than length of prices. It's kind of ugly, but it just makes it a little bit easier. But then you'd have to multiply that also by int day less than length of prices. Whatever. That's fine. Okay, and then not holding on a day, because this could be outside of the boundary. You decide to not hold on the day. You either can not hold from the previous day, or you sold 2 days previously. So not holding on the day equals the max of not holding on the previous day, or you were holding 2 days ago and you get the price from the previous day as a response, right? Is that right? Sorry, I'm starting to get tired because it's getting late and I'm right. I either decide to continue not holding, or I sold 2 days ago, so I get the price from yesterday. All right. So I sold 2 days ago because I was holding 2 days. Whatever I got, whatever the max amount of money I could have holding 2 days ago, plus the prices from yesterday, because that would be the money that I get. And at the end, I would just return not holding, right? Because not holding at on the last day. Okay. So, I guess one thing about this problem is, like many dynamic programming problems, I'm foolish and I did something wrong. Oh, gosh. 1, 1 should be 0. Does it link the prices? No. Plus 1. It should be plus 1, but then why is 1 giving me... Okay, so not holding on day 1. Well, this is day 0. So if I bought here on 1, not holding 0 on day 1 would be not holding on 1, not holding on the previous day would be 0, holding 2 previous days, the problem is that this is because the previous day yikes, man, what am I doing wrong here? Okay, so let's think about this in terms of one element. Yikes, man, I apologize. So 1 can either decide to sell it or do nothing. And I could sell it here and I could get 1. Or I could continue doing nothing. So when it gets to 1, yikes. I guess because day minus 2 is, it's non-existent, right? So if I set this to negative infinity, problem is it's trying to reference a day that's like back here. Right, but there's no day back here, so you can't do that. So maybe that'll fix it. Try to get cute, and then everything messes up. It's usually how it goes. Why is it still saying 1? All right, there we go. So the thing is, we're going to fix this right now. I'm sorry that I got the little bug, right? Because if you can't, like, there's like certain edges in this, the way that I have this recurrence relationship set up, that you're like basing things off things that don't exist. So it shouldn't return 0. It should return negative float infinity to basically specify that this can't exist, so don't try to use this as a solution. And that's why we encountered a problem here. But what you'll notice here is that everything's based off of previous days. So we don't actually need to keep track of the whole system, right? It's not like this information is important at this point. So I'm going to quickly turn this into a constant space algorithm by getting a little intelligent about how we're going to do this. So what I'll do is I'll just use holding and not holding and prev holding. Okay. So I can use these 3 constants, and I could say, well, holding at a day is the maximum of holding at the previous day. Not holding, the previous day's not holding, minus this times this, okay. Not holding now is what not holding used to be. This would be prev holding at the previous day. Okay. So then maybe these should be, no, because that'll be the value of the first day. I'm really screwing up here today, guys. All right, but then this would need to be done all on the same line. That way, it's all based off the previous states. And then previous holding would just become what holding was before. And then the best you could get is whatever not holding is at the end. Oh, come on. So I'm basically just taking something that's linear space and turning it into constant space by keeping pointers of the corresponding vertices we need for any compute. But I'm worried that there's still going to be that issue of, yeah, when the length is 1. So we'll just call previous holding float negative infinity, and I think that'll fix it. Because previous holding will only get populated once you've, yeah, okay. So there you go. So now you've turned this into constant space, and you can technically also make this, sorry, a 3-line solution. I apologize, guys. I kind of lost my momentum there at the end. Hopefully there was some stuff you learned. At least the graphic was good, but my code was bad because, you know, there's edge cases with this system, right? One thing to always think about when you're solving these problems is, like, just because your recurrence relationship works in the center, there can be weird edge cases at the end that you need to think about. And you can either split up your cases, right? You could figure out manually those first cases, and then for the meat of it, do some standard recurrence relationship, and then figure out the values at the end, right? And then think about, you know, smaller cases where there's just one thing or two things or whatever. Or you can just kind of have code that has a general approach where it captures all of those edge cases by, you know, by creatively setting your initial variables. Okay. So with that said, what is the run and space complexity of this problem? Well, let's say n is the number of stock so that you could buy. For time, well, setting this is constant time, right? It's just 3 variables that you set. And then you're going to look at each day, right? Proportional to the number of days. So you're going to look at each n days, and then you're just going to do a constant set of operations, right? It's a constant operation to find the max between 2 things. It's a constant operation to find, you know, the max of 2 other things. And it's a constant operation to set the previous holding value to the current holding value. right? That's all constant. So for all n things, you do something constant. This is constant. You do n constant things, and then you return something which is constant. So constant plus n times constants, some constant, plus constant is just O of n. Okay. For space, well, we create these three variables, and regardless of the number of days that we have, we just continue to update these three variables. So if there was 1,000,000 days worth of prices or 2 days worth of prices, we'd always only have these three variables. So that's why it's O of 1. So essentially what I did is I took, this recurrence relationship and basically said, well, we could have a case where we keep track of everything, but you only really need to keep track of what, right? For any generic graph, right? The only thing you really need to keep track of is you need to track of this, which is the holding value. You need to keep track of this, which is the not holding value. And then you need to keep track of whatever holding was before. Right? And for those three things, you can calculate any, additional link or whatever. Okay. So, again, I apologize for the loss of momentum at the end. That just goes to show that maybe it's not always the best case to try to capture everything in your variables and split it up into okay, for the first values, this will be the recurrence relationship. For the values in the middle, right, this will be the recurrence relationship. For the last values, this will be the recurrence relationship, and then just do it like that. But this is short, and short is cool, unless you're playing basketball. Peace out.